Good morning, good evening and good night. Welcome to this lecture number 4 on redox reaction. So far we have discussed different aspects of this chapter. In the first lecture we have discussed about the classic idea of the oxidation and reduction reaction. Then in the second lecture we have correlated with this oxidation and reduction ideas with the electron transfer when there is a chemical reaction is going on. That we correlated and we understand that it is the oxidation process is basically the losing of the electrons and the reduction process is the gaining of that electrons. And we understand what is reducing agent and what is oxidizing agent. Reducing agent itself is oxidized and the oxidizing agent itself is reduced. So, and also we understand the oxidation number. It is a very easy tool to understand about the status, oxidation status of a element in a compound, whether this element is oxidized or whether the element is reduced, that we can easily able to understand from this oxidation number. When the oxidation number has increased of a substance while it is in reaction, we will say this is oxidized, and reduced means there is a decrease in the oxidation number. That is a very important thumb rule by which we can able to understand about the oxidation state of the element when in a compound. In this lecture we are going to discuss some very essential questions. These questions will going to clear your ideas, because when we study anything we need to understand how far we have learned. That is a very important thing, because you are investing your time and you must know how far you have cleared the concept in terms of your examination purpose. So in this lecture we will discuss some MCQs. So heading of this lecture is MCQs in this redox reaction. MCQs means multiple choice questions. The questions I will give, that will we have some multiple choice and you have to understand. The most important thing that when I give a question, you can pause the video and try to solve yourself. If you solve yourself means your conception is clear. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. This is the first question that we are going to discuss. Question number 1. That is, we have to say determine the oxidation number. Determine the oxidation number of oxygen in KO3 and NaNO2 into O2, sodium peroxide. There will be multiple choice is given. That is, first choice you have given, that is minus 0.33 and minus 1. Second choice is given 0 minus 1. Third choice is given 2 and 3. And fourth choice is given none of the above. So you have, there is a choice is given. Among these you have the one choice is correct and you have to answer it. So when we are going to determine the oxidation number, at that time you have to see the species that we have been given for examination. That is, whether this species is neutral molecule or the ions. So here you can see both are neutral molecules, and we have to know the one of the elements, oxidation number of the one of the element, and we know potassium or your sodium is oxidation number is fixed, it never changes. It is having the +1 and it is having the +1. So we can easily able to calculate, let the oxidation number of oxygen is X. Suppose this is X. Then oxidation, first we put the oxidation number of sodium is potassium is 1, and the X is the oxidation number of the oxygen. So we can write 3 into X, and that is 0 because it is a neutral molecule. So you can write -1/3. Okay, this is simple. For NaONO2, this is for the CO3, for oxygen molecule in the CO3, and this is you get 0.33 minus. And here also we can calculate sodium, that is 2 molecules, so 2 into 1 plus we have to calculate the oxidation number of the oxygen, that is 2 into X, and that is also in the 0. So we solve it, it will come in around to -1. So it will be the -1. So what will be the right answer? Right answer will be this. Okay, in this way we can able to determine the oxidation number of this. Second question, again this will regarding the oxidation number. Determine the oxidation number. Determine the oxidation number of COCl2. See, here there is a 2 chlorine atom, and question arises whether these 2 chlorine atom have the same oxidation number or not. So choice is given here, that is 0, 0. Second choice is given here, that is +1, -1. Third choice is given here 1, 2, and last choice none of the above. So for this, first we have to see whether this is a neutral molecule or a charged ion. You can see from this formula, it is very, very easily understood that it is a neutral molecule. And if it is a neutral molecule, then in this case, what we have to do? We have to go to the structure of this molecule. And the structure of the molecule is, you can see, it is, you can write Ca, OCl minus and Cl. This is the structure of the molecules. So here you can easily understand this. If you calculate this and if you calculate the chlorine oxygen number of this chlorine atom, so you have to see this is basically charged particle. So we know the -2 is the oxidation number of oxygen, and we have to calculate the oxidation number of the chlorine. This is X, and it is a charged one, that is -1. So what we get? X is equal to +1. At the same time, we know chlorine has the negative -1. So what will be the right answer? Right answer will be 2. So you have to always understand the structure of the molecules. In this case, you can see. And this type of another question that we can understand, that is the question number 3 here given. Question number 3. Question number 3 you given. You have to arrange oxygen. Arrange the OE of oxygen. ON of oxygen. Oxygen number of oxidation number of oxygen in the arrange in increasing order. In increasing order. in the molecules, you have given BaO2, second you have given KO2, third you have been given O3, and fourth you have been given the OA2. You have to arrange the oxidation number of these molecules, oxidation number of oxygen atom of these molecules in an increasing order. First you have to start from the lowest oxidation number and you have to finish with the highest oxidation number. How do you do that? And for that you have to again calculate the oxidation number. So oxidation number of BaO2, you can see it will be -1. Oxidation number of oxygen in the BaO2 is -1, and in the KO2 it will be -half. In the oxygen O3 it is 0, and OF2 it will be +2. So you can easily understand that is by default has been arranged in the increasing order. So you can write the oxidation number of the oxygen in this molecule in this increasing order, BaO2 the lowest, then KO2, then O3, and then OA2. This type of questions normally comes in your exams. So we have the three very important questions that we have discussed. Now we are going to discuss another very important question that will be basically in the forms of numericals. Okay, you have to say in the reaction which species is oxidized, which species is oxidized. You have to say the equation is this: H2O2 Na2CO3, and it is being Na2O2 plus CO2 plus H2O. This is a balanced chemical equation, and you have to see which species has oxidized. So you know the species which is going to oxidize, its oxidation number will be increased. The species which reduce its oxidation number will be decreased. So what we have to do for this type of question, you have to first calculate the oxidation number. Oxidation number of hydrogen is +1, in this case it is -1, it is +1, and if you calculate it will be +4, and if you calculate -2, again +1, -1, +4, 2, +1, and -2. Now you see where there is a increase or decrease of oxidation number. Now as for example, hydrogen here you can see no. Oxygen you can see there is this oxygen, this oxygen, this oxygen, this. So what you find here, there is no change of oxidation number of the reactant or the product. So we can say none of the species is oxidized. So here will be different multiple choice will be given here, and one of the multiple choice will be none of the species oxidized. That will be the right answer. Okay, this type of question, confusing question, will come. This was the question number 4. Now we discuss the question number 5. This is basically a numerical. In a compound, it is found that is formula is M.98. This is oxide. Compound is oxide. And it is also found that why M is 0.98 fraction, that you will know in your solid state chapter when you are studying the solid defects. At that time you will understand why this type of formula is coming. It is a fraction number. Why it is coming like this way? This is basically this is a imperfection in the solid that we will discuss when we are going to the solid state chapter. So normally what is going to happen? Why it is 0.98? Because this metal is present. This metal is present. This metal is present in M3 plus and M2 plus in oxide. Question. What is the question? Question is calculate the percentage of M3 plus in the oxide. Here option is given here. Option is given. That is number 1 option. That is 4.08. Second option 6.02. Third option is 8.2. And fourth option is 1.02. What will be the right answer? How do we solve it? Let us understand. First we take, suppose we have taken 1 mole of this oxide. 1 mole of this oxide. So in this 1 mole of oxide, what will be there? It will be that you can see in this 1 mole oxide there is 0.98 mole of M metal in ionic form. That is, what is the ionic form? The M3 plus, M2 plus, and oxygen in 1 mole. So oxygen is 1 mole and this. From this molecular formula we are able to check. So suppose X is X mole of M plus 3 metal presents. M plus 3 present, suppose. So what will going to happen? Then we can say 0.98 minus X will be M plus 2. Here we have to balance the charge. We know this is a neutral compound and the neutral compound will have the 0 charge. So, but here metal exists as in a charge, that is M3 plus, and oxygen also it will have some charge, it's a minus 2. So when we balance the charge, so it will be coming around like this. This I am going here. The equation will be 0.98 minus X into 2 plus 2, that is, and X into 3 minus 2 is the oxygen and this is 0. 96 minus 2x plus 3x minus 2, that will be 0, and it will be coming around x minus 0.04, that will be 0, and it is coming around, that is, you can see it will be going around 0.04. And when we are converting this 0.04 into the percentage, it will be percentage with 0.9 0.98 moles, you have this 0.04 moles of this N3 plus. So at that time, how the percentage you will calculate that it will be coming at a point. So that you can easily and able to understand that this will be the percentage is 4.08. Okay. So here in the question that will be the answer. Tetrahydromethyl ion. Oxidation number of sulfur. The choice is given from the left to right hand side because there is a 4 sulfur and all the 4 sulfur will have the same oxidation number or different oxidation number that we have to determine. And it is given the plus 5, 0, 0, plus 5. Another choice is given plus 3, 0, 0. Another choice is given, that is plus 1, 2, 1, 3. And fourth number choice is given 1, 2, 1. So what will be the right answer among these 4 multiple choices? This is a tetrahydromethyl. You have to calculate, you have to determine the oxidation number of the 4 sulfur. And the 4 sulfur will have the same oxidation number or different oxidation number. From the multiple choice you can easily understand it will be different. Among these there will be the one answer will be there. And we have already discussed in our previous lecture in the oxidation number that this type of things actually if you want to know the actual oxidation number, you have to go to the structure of these molecules or these ions, and you have to see the bonding, how they are bonded. So for that we have to first understand its structure. This is a 4 sulfur atom is arranged like this way and the oxygen is arranged like this way. Now it has been experimentally found that is the oxidation number of these two will 0. And so the oxidation number of this sulfur and oxidation number of this sulfur, suppose this is X. So we can write this, it is a charged species and charged ions have the -2 oxidation number. So we can write this equation 2X. That is for this 2 sulfur plus 0 into 2 because it is have the 0 oxidation number, and all the 6 oxygen atom have, you can see how many oxygen atom? This is 6 oxygen atoms, 6 into 2, or you can say -2. So and this will be the -2. So 2x plus 0, this is -12 -2, and if we get it to x, it will be +5. So x will be +5. So in this case, what will be the answer? The answer will be this +5, 0, 0, +5. This will be the answer. Okay. Another question, that is a question number 5. Another question that we are going to discuss, that is in the form of numericals. Five and 6. For this type of question, that you have to first calculate, first determine the empirical formula. And for this empirical formula, that you have been given the percentage, and from this percentage you can able to know the this is 53.44 means 153.44, that is 6. This is 46.56. That is the percentage of fluorine. So we can write is 53.44 is to, that is 46.56 divided by, you can see that is coming around 133, and divided by it is 90. So if we calculate this, it will be coming around 6, it will be coming around 1:6. Means the formula of this xenon fluoride will be 6. So we know the fluorine has the oxidation of -1, so xenon will be oxidation number of 6. So this will be the right answer. Halide is oxidized by halogen. Reaction is given here. Number 1, Cl2 I minus Cl minus plus I2. Second option is given I2 Cl minus I minus plus Cl2. Third option is given Br2 plus Cl minus is equal to Br minus plus Cl2. Fourth option is given Br2 plus I minus is equal to so among this following reaction, you have to say in which reaction the halide has been oxidized by the halogens. Or that what we have to see, or we have to see the potential that we will discuss in the next lecture, that we will understand the displacement reaction. In the displacement reaction, it is observed the halogen which have the higher oxidizing capacity than the other halogen, it will displace that halogen from its compound. As for example, here you can see, as per this, if we go by this, the chlorine will have the highest oxidation, chlorine. Here we are using the chlorine, then that is followed by bromine, bromine is followed by iodine. So in this case, what is going to happen? Chlorine will be highly oxidizing power, high oxidizing power than this, because here in this reaction the chlorine is reduced, because chlorine has the oxidation number is 0 and it is oxidation number is decreasing, and it will easily able to displace the lower, that is bromine and iodine, from the solution. Here you can see the chlorine displaces the iodine. Iodine form its compound, that is Ai, where the iodine never displaces the chlorine from its solution, because iodine has lesser oxidizing power than the chlorine. So this answer will be the right answer, that chlorine gas will easily oxidized. It has a higher capability to oxidize than the iodine or than the bromine. So it will the most that is the actual up-to-date answer, that is which halogen oxidize the halides, that will be the chlorine. Here you can see iodine cannot displace the chlorine from its compound, because it do not have the higher oxidation power than the chlorine. In case of bromine, you can also see this reaction. In this reaction also, bromine is not going to oxidize the chlorine because it do not have the higher oxidation power. So this will not be the right answer. This will not be right. This is not right, and this is not right. So right answer would be this. So that is all for today's lecture. In this lecture we have discussed very important questions and some numericals that will help you to understand the concept of oxidation and reduction numbers. So if you like this lecture, you can share to your friends. Thank you for watching this lecture. Next lecture we will discuss the types of redox reaction. Thank you very much for watching.